This week's topic actually happened and made history a couple weeks ago, but the first attempt was postponed and rescheduled because of the weather, the SpaceX launch. The long-anticipated launch of SpaceX Dragon capsule was originally at 4:33 p.m. on Wednesday, May 27th at the Kennedy Space Center in Florida. Scientists and weather experts were keeping a close eye to the weather conditions as isolated storms were in the forecast. According to NASA, the primary concerns are flight through precipitation, anvil clouds, and cumulus clouds. Atmospheric scientists have learned that rockets generate an electrically conductive exhaust plume that can trigger lightning when passing through a pre-existing electric field, which is usually from clouds containing both water and ice. And these are typically found in tall cumulus clouds, or the anvils of thunderstorm clouds. Outside of the launch site, there are also some areas of concern with the potential for lightning storms, high winds, and waves along the flight path. All weather conditions need to be within acceptable limits for both the launch and flight path for the launch attempt to be a go. The SpaceX Dragon mission also operates under what is called an Instantaneous Launch window, or a narrow period of time during which atmospheric conditions are open for flight. The rocket has to launch at a specific time. This is because it needs to send the spacecraft on a trajectory that will meet the International Space Station in orbit around the Earth. Around 2 p.m., showers and storms were on radar. A tornado warning was even in effect until 2:15 in Brevard County, which is about 20 miles north of Cape Canaveral. Remnants of Tropical Storm Bertha were still in the area and causing lightning strikes to hit a few miles off the coast of the launch site. Additionally, severe weather off the coast of South Carolina was a factor that launch directors were monitoring, as conditions on the surface of the Atlantic Ocean could affect the spacecraft in the event of an abort mid-launch. Therefore, 17 minutes before the scheduled launch time, officials postponed it. The launch was then set for Saturday, May 30th at 3:22 p.m. with hopes of more favorable conditions. Come Saturday, scientists and weather experts were keeping an eye on the conditions as there was a 50% chance for storms. The main trigger for showers and storms this time was from a cold front approaching Florida from the northwest. 2 hours ahead of liftoff, the crew was settled in and the hatch was closed. But the weather, not exactly cooperating with showers around. An hour later, conditions have improved and the weather is a go for launch. The SpaceX Demo 2 successfully launched at 3:22 p.m.
7, 6, 5, 4, 3, 2, 1, 0. Ignition. Liftoff of the Falcon 9 and Crew Dragon. Go NASA, go SpaceX, Godspeed, Bob and Doug.
America has launched. And so rises a new era of American spaceflight, and with it the ambitions of a new generation continuing the dream. 20 seconds into flight, stage 1 propulsion is nominal.
It was a 9-minute ride to reach orbit and then a 19-hour ride to the International Space Station. NASA astronauts arrived at the International Space Station Sunday morning at 10:16 on May 31st. This marks the first time in history that NASA astronauts have launched from American soil in a commercially built and operated American crew spacecraft. Obviously, some very different conditions for those astronauts in space, and that also includes the weather. No rain or snow like within our atmosphere, but space weather comes in the form of solar radiation, geomagnetic storms, and much more. Space weather includes all conditions or events that occur in outer space near Earth or in Earth's upper atmosphere, also on the sun and the solar wind. The sun is the main source of space weather, and the steady stream of particles blowing away from the sun is known as the solar wind. Just like the National Weather Service forecasts weather and storms locally here on Earth, NOAA's Space Weather Prediction Center forecasts solar storms and is the official source for space weather forecasts for our nation. To predict these storms, forecasters watch the sun for solar flares and coronal mass ejections. Solar flares are massive explosions on the sun's surface. They often arise near sunspots and release a wide spectrum of photons, such as X-rays, visible light, and ultraviolet light, outward into space. The biggest solar storms arise from coronal mass ejections. A CME is an enormous bubble of plasma expelled by the sun. It contains billions of tons of fast-moving solar particles, as well as the magnetic field that binds them. Earth's magnetic field helps to protect us from the effect of some solar storms, but some solar storms can be strong enough to cause disturbances in our radio communications, GPS, power grids, and satellites. We have seen some problems related to space weather, such as outages and loss of data in weather satellites, since they began operating in the 1960s. One of the best known examples of space weather events is the collapse of the Hydro-Quebec power network on March 13, 1989. A powerful geomagnetic storm set off a major power blackout in Canada. It left 6 million people without electricity for 9 hours, and it even melted some power transformers in New Jersey. The geomagnetic storm that caused this event was the result of a CME from the sun on March 9, 1989. Back here on Earth and at home, for your 7-day forecast, scattered storms return by the afternoon and the evening. Storms do continue into Thursday morning with a cold front crossing through. Dry skies after that with less humidity into the weekend. Stay safe, healthy, and see you for next Weather Wednesday.